Hey you brilliantly blinking Bytemeisters, it's Prof G. You're in our next lesson in CircuitPython school, and it's time to get flashy, using the NeoPixel lights on our CircuitPlayground board. And while doing so, we'll get a first look at the time library. If you're here, I'll assume you have a CircuitPlayground board, Bluefruit or Express, that it has the latest version of CircuitPython installed, and that you've installed both Circup and PyCharm for coding. If not, you can start at the beginning of the playlist for a gentle and newbie-friendly introduction. For everyone else, make sure that your CircuitPy board is plugged in. Let's get into PyCharm, open the project we used in our last lesson, make sure you're in the code.py file in your CircuitPy board. If you need to make a backup and save this code, do so now. When you're ready, let's start by deleting the code that we wrote earlier. And in this first example, we're going to get our board to light up in blue. Now, it's always a good idea to document your code. We can do this by adding comments. Comments are lines that do not execute. Python comments start with a number sign. Some folks call that the pound sign or the hashtag. So I'm going to start by typing number sign space lighted up dash light up a CircuitPlayground. Now, since we're referring to features on the board that we have plugged in, we're going to use a special CircuitPython library called board. Now, we can access that board library and all of its features in our program by using the Python import statement. So type import, then space, then the name of our library, which is simply board, B-O-A-R-D. Now, we often use the board library to refer to features that are built into any board that we're using. For example, later in this lesson, we'll see that we can refer to board.neopixel, all in caps, to refer to the NeoPixel lights on the board if there are any. In another example, in a later lesson, when we work with add-on hardware, if we connect, say, a light strip to pad A1, we can refer to that as board.A1. Now, this is a bit strange. On my project, at least, the word board and just board should be showing up in code completion, but it's not. But I'm not getting a squiggly red error line under the word board, so this is going to be okay. Now, since we also want to control the NeoPixel lights on the board, to get the functions and values to use them, we need to import the NeoPixel library. So on this import line, after board, we can add a comma, a space, and then the word NeoPixel in lowercase. But watch this. We're going to run into a problem. As I start to type in NeoPixel, N-E-O, PyCharm doesn't seem to recognize this. Hey, if PyCharm knew about NeoPixel, then code completion should be recommending that word. Let's continue to type NeoPixel, and oh, we see a red error squiggly. If we hover the cursor over it, it says no module named NeoPixel. Not good. Here's the problem. In the lesson on installing PyCharm, we added the basic CircuitPython-stubs to this project. Now, stubs know about the board library, but the NeoPixel library is something extra on top of that. That's because not all CircuitPython projects use NeoPixel lights, and if we added the library to every project when it wasn't needed, it'd just take up precious space. Well, let's tell our PyCharm project to include information about the NeoPixel library in the same way it added stubs. We're going to head up to the PyCharm settings, Mac that's under the PyCharm menu, Windows it's under the File menu, choose Settings, then Project, then Python Interpreter, and then we'll click on the plus above packages just as we did with the CircuitPython-stubs. And remember, we have hundreds of potential libraries to include here. Now we can search for the name NeoPixel in the search box, but be careful. This brings up a bunch of libraries, including one that's named simply NeoPixel that you might think is the right one, but it's not. All the official Adafruit packages where our libraries can be found start with Adafruit-CircuitPython-. So remember that. The one we want is this one here, Adafruit CircuitPython NeoPixel, not the SPI one. So click that, then click Install. It might take a couple seconds to install, then click Close. And whoa, there's a lot of stuff in the package list now. Don't worry, all that is supposed to be there. PyCharm will recognize lots of statements that have to do with NeoPixel lights. Click OK, and dang, when you look at that, the red squigglies have vanished. No error, PyCharm now knows about the NeoPixel library. And you can verify this by deleting the word NeoPixel, typing it again. Nice. Code completion is there. Cool. By the way, NeoPixel is an Adafruit Corporation term for a particular type of LED light that can shine in any color. There are 10 individually programmable NeoPixel lights built into CircuitPlayground boards. Some other boards have only one NeoPixel light, some don't have any. The Raspberry Pi Pico boards don't have any NeoPixels either. Now, the board library actually knows which boards have NeoPixel lights and how to access them. Now, later in the course, we'll also use external strands of NeoPixel lights, and we'll connect them to all the boards we use, including the Pico. Now, one other thing to be aware of, you need the NeoPixel library inside your CircuitPy board's lib folder, but we added that back in our circup lesson. If you find yourself needing to install the NeoPixel library on your board, you can head to the terminal and enter the command circup install Adafruit_NeoPixel. That'll do it. Now, this NeoPixel library will contain commands we need to work with any of these lights, whether they're on board or in strands. Now press return twice to give yourself some space and start on a new line. Now before we can actually flash our NeoPixel, we need to write a statement that says where our NeoPixel lights can be found and how many of them there are. So what I'll show you on this slide are the lines of code that we need to write whenever we want to set up NeoPixel lights on a CircuitPlayground board in CircuitPython. First, we started already with import statements that said bring in all of the statements related to boards and all of the statements related to NeoPixels. Now here's the statement we're going to write to set up our NeoPixel lights so that we can refer to those lights and manipulate the lights in our code. So to refer to lights, first we need to give them a name. So the name we're going to use is going to be the word pixels, all in lowercase. Now we could have chosen just about anything for a name, Jennifer or Lady McLightface, but Pixels is a good name and it's one that you'll find in CircuitPython example code, so we'll use it here. Now this name we're referring to is what in computing is called a variable. Now a variable is just a name we use to refer to data, and that data can be changed. Now I like to think of a variable as a named box that has data inside of it. Our variable named Pixels is like a box named Pixels, and if you look in that box you're going to find data that points to the 10 NeoPixel lights on our board. Now in our code we specify that the lights are on our NeoPixel board by just saying board.NeoPixel, all in caps. This statement behind the scenes will get our code to the right electronic pathways to work with those lights. Now, if we were clipping a strand of lights, say to pad A1 in our CircuitPlayground board, and we're going to do that in a future lesson, we would instead write board.A1 here, because those lights would be attached to pad labeled A1. Now there are also 10 lights on our onboard NeoPixels, so that's why we have a 10 here, the number of lights. And now in Python, the NeoPixel lights we're setting up are referred to as something called an object. Now an object is simply a data structure, a group of data organized in a particular way. By creating a NeoPixel object, we get a value that we can refer to control NeoPixel lights. We're going to call our object pixels, and we'll see later on that that object also controls additional functions like fill, which we'll use to fill in the lights with a particular color. It'll also contain values that we can change, for example, to alter the brightness of lights, and NeoPixel objects have all sorts of additional capabilities. So this NeoPixel library up here that we imported with all lowercase, this contains the blueprint for creating a NeoPixel object, capital N, capital P, whether it's on the board or whether it's clipped to the pad. Now in computing, we say that the blueprint for creating objects is called a class. I know we're getting a lot of terms in here, but it's important to know them. Now our class, again, the blueprint to create NeoPixels is called NeoPixel, but with a capital N and a capital P. Now when the class name, the blueprint for creating objects, is followed by parentheses, those parentheses almost act like a factory. They say take the blueprint and create an object. Now, in between the parentheses is the data that's required to create an object using the blueprint of the class. So we read this line like this. Go to the NeoPixel library, which we imported, find the NeoPixel class, capital N, capital P, and then with the parentheses here, go to the NeoPixel factory using the NeoPixel blueprint and taking these two inputs, board.NeoPixel, comma 10, and create an object that we can use to point to the 10 lights that are on our board, and we'll call that object pixels. Now you can use this code over and over again whenever you need to refer to the 10 lights that are on your NeoPixel board. By the way, Python is super fussy about getting capitalization right, but this can confuse new students because we have some words that are in all caps, some that are in mixed caps, and some that are in all lowercase. Well, the reason for that is there are different conventions or styles that programmers use for different types of data or data structures. So briefly, the standards are any values that are supposed to be unchanged and remain constant should be written in all capital letters. So since this refers to NeoPixel lights that are permanently on our NeoPixel board and they can't be changed, the name NeoPixel that you see here is written in all caps. Another convention is to write class names like NeoPixel here as one word, but with a capital letter at the start of each of the sort of words inside of the word, like capital N Neo, capital P Pixel. That's referred to as the upper camel case style, since the capital letters look sort of like the humps of a camel. Now you'll also notice the convention is for variables like pixels or function names like print, as well as library names like board and NeoPixel, to be written in all lowercase letters. And if a variable has more than one word in it, the convention is to use an underscore to separate the words, and that style is called snake case. So now let's enter that line that we just discussed. Pixels, our variable name, equals NeoPixel lowercase. Again, that's the name of this library that we imported up here. And we should go inside that NeoPixel library and find the NeoPixel class. So we write dot, that brings up a bunch of options, and we want NeoPixel with capital N, capital P. That's our class blueprint, which is inside this NeoPixel library. And so to use this blueprint, or as it's actually called in computing, the class, we'll tell that NeoPixel class to act like a factory by adding parentheses. then that factory needs inputs. So first is going to be the location of the lights on the board. So we type in board dot, but we're going to run into a problem as we start to type in capital N-E-O. Dang! Code completion doesn't seem to know about all caps NeoPixel. Thwarted again. So here's the scoop. The board library knows all about all of the boards, but PyCharm does not know which board we have plugged in. Now, some boards have NeoPixel lights, some don't. So I want to tell PyCharm I'm using the CircuitPlayground Bluefruit board, and when I do that, it'll give me access to board.neopixel since there are NeoPixel lights on that board. Here's how we set the board type in PyCharm. Open up the PyCharm terminal, and here's another jump cut with more important information. So if you quit PyCharm and then you restarted and got into the terminal, you should see the percentage prompt. But if you didn't quit PyCharm and you last had TIO up and running in the terminal, then TIO might still be running and you won't see the percentage sign prompt in the terminal. Now, if you want to get to the percentage sign prompt, you should be able to type Control-T on either Mac or Windows and then the letter Q, and that should quit you out of TIO and return you to the percentage sign prompt in the terminal. But I found out that sometimes this doesn't work. I'm not exactly sure why. And if you're stuck in TIO, what should you do? Well, you can quit out of PyCharm and restart it, but you can also click this little X mark here next to the local tab above the terminal. You can then click the terminate button. This closes the terminal, but if you click the terminal icon again, you'll be back in the terminal at the percentage prompt without TIO running. Now, to recognize the board options for the board we're using, which is why we want to be at the percentage prompt in the first place, enter in all lowercase CircuitPython_setBoard. Setboard is one word, space, then the name of the board. For me, that's going to be CircuitPlayground_Bluefruit. If you're using a CircuitPlayground Express, that's just CircuitPlayground_Express. Here are the names of the two Raspberry Pi Pico boards, but I'll cover those in another lesson. Then after I press return, it says setting board. All looks great. And now back in our code, if we start to type Neo, all caps again, we see NeoPixel shows up as an option because there are NeoPixel lights on the board that we just defined using setBoard. Cool. Then we follow board.neopixel with comma 10 since there are 10 lights on the board. And for some reason, PyCharm adds an N in front of the label that represents the number of lights. That's okay. It's unnecessary, but we can leave it there. And we should really put a comment above this line. How about hashtag set up our 10 NeoPixels on our board and call them pixels? And why don't we click to close the terminal window to give us more coding room? So to get our pixels, our 10 NeoPixel lights to light up, all we need to do is type pixels. That refers to the object that refers to the location of the NeoPixels that we created up here. So this object pixel is of class NeoPixel, and we'd mentioned that this class or this blueprint has a bunch of functions and additional data associated with it. We access that with dot notation. So if we type dot right after the word pixel, we see a bunch of different options in here, and we want a function called fill. So if we start to type in fill, there it is. We're going to pass in a color, press return. All Python functions have parentheses around them, and now inside this, we pass in the inputs for this function to turn all of our lights a particular color. We're going to pass in a color. Now, one way computers create colors is by mixing 3 different colors, red, green, and blue. Now, we're going to use a standard method where the intensity of color goes from 0, no color, up to full color, which is the number 255. Mixing 3 colors at those levels from 0 to 255 can theoretically produce over 16 million colors. Now, the colors don't always look true on LED lights, but we can still produce some pretty cool effects. Now, CircuitPython colors have those 3 numbers, 0 to 255, separated by 2 commas in between another set of parentheses. So in our fill function, we're going to add a second set of parentheses, and in between here, to get blue to show up, we're going to say 0 for our red, we don't want any red, comma, 0 for green, no green, comma, and 255 for blue, full on blue. Now, before we save and run, we want to launch the TIO program to connect to our board. Remember, we did that when we were working with our print statement in the previous lesson, so we can open PyCharm's terminal again. And remember, we used the TIO command. Now, when we first used the TIO command, we needed to find the name of the tty.usb modem. It had a special number associated with it. We copied a whole line that was from /dev all the way to the end of the number, and then we typed in TIO and pressed space, and then pasted that line in. Now, you can perform those steps again, but remember our terminal shortcut. The up arrow on our keyboard will show the last command that was entered in our terminal. Now, that was our setboard command, but if we press the up arrow a second time, hey, that's the TIO command with the correct /dev string that I copied in the previous lesson. You likely have a different number after your USB modem, but if you follow the lessons and your board is plugged into the same port, you should have the correct command here. So the up arrow is a huge time saver. I'm going to press return. We see a few lines of output to indicate that TIO has launched. Wonderful. Now another jump cut to point out something important. If you ever try to connect to your board and you get a message like this, warning, could not open TTY device, no such directory, then what's probably happening is you need a different number after the USB modem part of this command. Now this would happen if you plugged your board into a different port on your computer, if you're using a different computer, or sometimes if you're using a different adapter, especially if you're using a USB adapter that has more than one port on it. So if you ever get this warning message, just return to the percentage prompt, usually Control T, then Q will do it. Then at the percentage prompt, enter the ls command that we just showed you. That's ls space /dev/tty dot star, all lowercase, press return, then look for the line with the USB modem in it, copy it from /dev through the end of the number, and then at the prompt enter TIO for TO space, and then paste in what you just copied and press return, and you should get the message that TO is connected to whatever line you just pasted in. Usually this happens within just a few seconds. Occasionally you have to wait over 30 seconds, and if things really start to get slow, remember you can quit PyCharm, unplug and replug your board back in, then get back in and try it again. The jump cut is over, back to where we were. Now we're gonna save, which runs our code, but we won't see the results that you might expect, and let me explain why. So I'll save my code with Command S, that'd be Control S on Windows. It'll take a second or two, and then you'll say TO indicates something happened. Code.py was running, and then right away it says code done running. And if you look at your board, all you'll see is the green flash every 5 seconds that indicates your code ran with no errors. Well, what's up? Well, what's happened here is the code ran, pixels.fill turned on all the lights in blue, but then the code ended right away. When code is done running on the CircuitPlayground, it'll turn off all the NeoPixel lights. So after we hit our pixels.fill command up here, there was no command that said stick around for a little while so we could see those lights while they're on. We just turn on the lights, immediately the code ends, and the lights go off. By the way, I can prove that this happens by putting print statements before and after my pixels.fill statement. And this is a good way to use print statements for debugging. Let me show you. So above pixels.fill, I'm going to type a print statement that says print, I'm about to turn on the lights. Then below pixels.fill, I'm going to put a print statement in that says print, the lights are blue. Then I'm going to Command S to save. It takes a couple seconds. And now let's check out the output. We see code.py run. We see our print statement, I'm about to turn on the lights. That's this statement here. Then we must have hit that statement pixels.fill because right after that we see the lights are blue. Then our code was done running, our lights shut off, and we didn't see the lights on at all. So what we need to do is we need to add another line after pixels.fill turns on the lights that would wait around a certain amount of time so we can actually see those lights. And we've got such a command. There's another library for us to use called the time library, and in that library there is a sleep function where we can pass in the number of seconds to sleep. Let's try it out. Now sleep is in the time library, but I'm going to try to enter time.sleep here without doing the import just to show you what's going to happen. Now most of the time this will give you an error, but PyCharm knows that there's a time library. It actually presents me with this option when I start to type in time. Ooh, look at that. Now the time library is actually built into the CircuitPython-stubs, so we don't have to go into settings and in the project's Python interpreter and import that package. And then when I type in the dot, I see the elements of the time library. I can start to type in sleep. This is what I want. Now when I press return in code completion, PyCharm adds the parens, and it did something else so fast that you might not have noticed it. My import statement up here was on line number 2, but now it's on line number 4. In fact, it looks like all my line numbers increased by 2. We'll explore that in a second. But first, in between the parens, I'm going to pass in the number of seconds to sleep, or wait before my program should continue. I'm going to say 3.0 so that my program waits 3 seconds after turning on the lights blue. And since this is the last line of my code, once the 3 seconds are up, my code will end and the CircuitPlayground board will turn off all of my NeoPixel lights. But if we scroll back up here, hey, PyCharm added an import statement for time. I didn't do that. PyCharm corrected a potential error for me. I actually would have preferred a clear error instead of it correcting things for me. I think that's better for learning as you code, but PyCharm really does have your back in many cases and will sometimes even correct your code for you. Now it's okay to leave this import statement on a separate line, but to keep my code neater, I'm going to cut out the time here and delete the first import statement, and I'm going to add this to the rest of the import line here with comma, pasting in time. Same results, it just takes up less space. Now let's save and run our code with a Command S. So you'll see the blue unsaved changes indicator go away. And look at that, TO shows our code is running and we see the lights on our CPB. And after 3 seconds, the lights go off. Now to run again, I need unsaved changes. So I'm going to add a single space, then I can Command S, the code will save. Unsaved changes goes away. My code runs, look at the output, it says the lights are blue And then after 3 seconds when the lights are off, I get my code done running message, and you should congratulate yourselves, electronics hacker, because you now know how to turn on NeoPixels. Now I want to show you one more thing before we get to the challenges. This triple number in a set of parentheses in here is not that friendly when reading our code. If someone were to look at this and see 00255, you might not necessarily know that's blue. But here's something that good programmers do. You can create a variable that's more descriptive and then reuse that variable. So up here, after I set up my pixels object, I'm going to create a new variable called blue, B-L-U-E. I'm going to use all capital letters because I'm going to consider this a constant and not change the value for blue. And I'll set it to the value equal to blue. Now that's these three numbers down here, including the parentheses. The parentheses are part of the color. You'll learn later on that that's referred to as a tuple or tuple. So cut out the color, paste it after the equal sign, and now whenever I refer to the word blue in my code, it's going to refer to that color in between parens 0, 0, 255. Watch what happens when I start to type in blue in between the fill functions parens. Hey, PyCharm knows about the blue value that I just created. It's in code completion. Nice. So if you save this with a command S, you'll see your code continues to work fine. It's just more readable. Now remember, you can comment any code you want if that helps your learning. So for example, following time sleep, I'm going to say hashtag space wait 3 seconds to remind me what this line does. Then let's save a backup of this code, head up to the file menu and select save as. We need to select the directory where we want to save this to, so we can click on the horizontal kebab over here on the right. I have my CircuitPython school folder on my desktop. I'm not going to save it inside the CPP project. I'll save it at the same level as my other code examples. Click open. My save directory is set, and now I'm going to change the name to 3-second-blue. My students, I'll ask you to upload this. Click OK, and it'll save. Notice I have another tab up top for my 3-second blue. I'm going to click on the X there to close that window, and now I'm just looking at code.py on my CircuitPy board. Now on to some challenges. First up is Tay Tay in Ireland. During a recent concert in Ireland, Taylor Swift wore the colors of the Irish flag and the fans in attendance went wild. The Irish Tourist Board has gotten wind of your mad CircuitPython skills and has asked you to write some code so that anyone can flash Irish colors at a concert just by plugging a CircuitPlayground board into a mobile phone battery. To do this, define 4 colors in your code: green, white, orange, and black. You can look up the RGB color values and experiment until you're satisfied with the results. Then flash each of these colors for 2 seconds each, then shut off all the lights, hint, use the color black, for 2 seconds, and then repeat once more, green, white, orange. When you're done, save this file as irish-flash.py. You can do it! The next challenge is Roy G. Biv. I want you to prepare for future work in our course by preparing colors that you can copy into new code. So I want you to define the colors for the standard observable light spectrum: red, orange, yellow, green, blue, indigo, violet, plus black and white. Then use the Roy G. Biv colors only, not black and white, in order in a new program file, flashing each color for 1 second. Include black and white in there too, though, so that you can copy and paste into new code. And I want you to save this file as roygbiv.py. Once again, I'm sure you can do it. Now, it might seem like we've only flashed our CircuitPlayground boards, but there was a lot of big learning in this lesson, laying the foundation for your future hacktacular work. We learned to use Python comments with a hashtag. We used the import statement on 2 libraries, board to access a board's features, and NeoPixel to work with lights. We added a package to our PyCharm project so PyCharm would know about a library. In our case, this was Adafruit CircuitPython NeoPixel to access the features of the NeoPixel library. We got an intro to variables, objects, and classes. We learned how computers define colors using RGB values, and we saw how to use these values with numbers between 0 and 255 to create colors. By the way, those 0 to 255 RGB values are referred to as 8-bit colors. We used the .fill function from the NeoPixel library. We let PyCharm know which board we were using by applying the CircuitPython setBoard command, and that gave us proper access to the board library features for our board. And we use the time library's sleep function. I hope you're feeling skilled. In the next lesson, we'll learn about loops so we can get our board flashing forever, over and over again, or for a specific number of flashes. Until then, continue to hack.